Hi there. This is a realistic DevOps interview focused on load testing and handling traffic spikes in real production systems. I am going to ask questions the same way a senior interviewer would, and after each one, I will walk through what a strong candidate answer sounds like. Before you listen to the answers, pause the video and answer the question out loud yourself. That is the best way to know where your thinking is strong and where it needs work. If you want to follow along with the rest of this interview series, subscribe so you do not miss the next one. Let us start with a warm-up question. Tell me about a time you were involved in preparing a system for a high-traffic event. A strong answer would sound like this. In one role, we were expecting a large spike due to a marketing campaign. My first step was understanding what kind of traffic we were expecting and where it would hit the system. I worked with product and marketing to get rough estimates, knowing they would not be perfect. From there, we reviewed historical data from similar events, identified bottlenecks, and ran targeted load tests on the critical paths rather than the entire system. We made small but high-impact changes, like increasing connection pools and adding autoscaling headroom. During the event, we had extra monitoring and a clear on-call plan. The event went smoothly, and afterward, we documented what assumptions were right and which ones were not. Next question. How do you usually react when something breaks under load and people are watching? A strong candidate might say this. I try to slow myself down mentally and focus on impact first. When something breaks during high load, emotions run high, but panic makes things worse. I quickly assess user impact, stabilize the system if possible, and communicate clearly about what we know and what we do not know yet. I avoid guessing publicly. Once things are stable, I shift to understanding why the system failed under load and what signals we missed. I treat it as a learning opportunity rather than a failure. Another one. Have you ever disagreed with stakeholders about how much load testing was enough? A good answer would be yes, and that is fairly common. Stakeholders often want certainty, while load testing can only give confidence, not guarantees. I usually explain what the tests cover and what they do not. I frame the discussion around risk instead of perfection. For example, I might say that we have high confidence in the checkout path, but less confidence in a rarely used admin feature. That helps stakeholders make informed trade-offs rather than arguing about absolutes. One more behavioral question. What do you do after a traffic spike, even if everything went well? A strong answer sounds like this. I always do a review, even if nothing broke. I look at actual traffic versus assumptions, how autoscaling behaved, whether alerts fired too late or too early, and whether any teams were overloaded operationally. Success can hide problems if you do not look closely. I document lessons learned, so the next spike is easier to handle. Now let us move into technical and scenario-based questions. First question. What is the difference between load testing and stress testing, and how do you decide which one to run? A solid answer would go like this. I think of load testing as validating expected behavior and stress testing as exploring failure modes. Load testing answers the question of whether the system can handle what we believe normal or peak traffic will be. Stress testing intentionally pushes the system past expected limits to see how it fails and how it recovers. Which one I run depends on the goal. If we are preparing for a known event, load testing is usually the priority. If we are trying to understand system resilience and graceful degradation, stress testing is more valuable. In practice, I prefer to do both, but at different stages. Next question. You run a load test and everything looks fine, but production still struggles during a real traffic spike. Why does that happen? A strong candidate might reason like this. There are many reasons. Load tests often simplify reality. They might not reflect real user behavior, cache patterns, or burstiness. External dependencies like third-party APIs might behave differently under real load. Also, production environments have background jobs, noisy neighbors, and operational tasks that test environments often lack. That is why I treat load testing as a signal, not a guarantee. When production struggles, I compare assumptions made during testing with what actually happened and adjust future tests accordingly. Another question: how do you choose what to load test in a large system? A good answer would be: I rarely try to load test everything. Instead, I focus on critical user journeys and shared bottlenecks, things like authentication, checkout, search, or any service that many others depend on. I look for fan in points where many requests converge. Testing those gives the most value. Over time, I expand coverage, but I always start with what would hurt users the most if it failed. Next scenario: your system auto-scaled correctly, but latency still increased significantly during a traffic spike. What would you investigate first? A strong answer could be: I would first check whether scaling actually reduced pressure on the bottleneck. Auto-scaling adds capacity, but not all problems are solved by more instances. I would look at downstream dependencies, database performance, connection limits, and queue backlogs. I would also check whether cold starts or uneven traffic distribution played a role. The key is to identify whether the problem is compute saturation, coordination overhead, or an external dependency that did not scale with the rest of the system. Final question for this section: how do you balance cost and safety when planning for traffic spikes? A mature answer would sound like this: I try to plan for safety first, but not blindly. I use historical data and business context to decide how much headroom we need. For known events, I am more comfortable paying extra for temporary over-provisioning. For unpredictable spikes, I focus on fast scaling and graceful degradation rather than always running at peak capacity. I also revisit decisions after events to see if we over or under-planned. Over time, that feedback loop helps strike a better balance between cost and reliability. Let us continue with deeper technical scenarios around load testing and traffic spikes. Here is the next question: how do you design a load test that actually reflects real user behavior instead of just raw request volume? A strong answer would sound like this: I start by accepting that no load test will perfectly match reality, so the goal is to get close enough on the things that matter. I look at production data first. Things like request mix, read versus write ratios, burst patterns, and how users move through the system. Then I design scenarios that model those flows rather than just hammering one endpoint. I also introduce variability, such as think time and uneven traffic, because real users do not behave like synchronized robots. If I cannot model something accurately, I call that out explicitly as a risk rather than pretending the test covers it. Next question: you discover that your database becomes the bottleneck during load tests. What steps do you take before deciding to scale the database? A mature answer would go like this: scaling the database is usually my last step, not my first. I start by understanding what kind of load is hitting it. Are we doing too many queries, inefficient queries, or unnecessary writes? I check indexes, query patterns, and connection pooling. Often the bottleneck is actually the application layer misusing the database. I also look at caching opportunities and whether some reads can be offloaded. Only after I am confident the workload itself is reasonable do I consider vertical or horizontal scaling, because that usually comes with cost and operational complexity. Another scenario: during a planned traffic spike, auto-scaling works but takes too long, and users experience slowdowns during the ramp-up. How would you address this? A strong candidate might explain it this way: I would first look at why scaling is slow. Is it instance startup time, container image pulls, or warm-up logic in the application? Depending on the cause, I might pre-scale before the event, keep a buffer of warm instances, or tune scaling thresholds to react earlier. There is always a trade-off here. Keeping spare capacity costs money, but slow user experience during peak moments can cost trust. For planned events, I usually accept higher temporary cost in exchange for smoother performance. Next question: how do you test and prepare for sudden, unplanned traffic spikes where you cannot pre-scale? A strong answer could be: for unplanned spikes, I focus less on predicting traffic and more on how the system behaves under pressure. I test rapid ramp-up scenarios where traffic increases much faster than normal. I also test failure modes, such as what happens when dependencies slow down or return errors. The goal is not to survive infinite traffic, but to fail gracefully. That might mean serving cached responses, shedding non-critical features, or rate limiting aggressively. I want the system to degrade in a controlled way instead of collapsing unpredictably. Another technical question: how do you decide which metrics and signals matter most during a traffic spike? A good answer would sound like this. I prioritize metrics that reflect user experience and system saturation. Latency, error rates, and throughput tell me how users are affected. Resource metrics like CPU, memory, and queue depth tell me where pressure is building. I try to avoid staring at too many dashboards at once. Before the event, I decide which signals will guide decisions, like when to scale manually or disable features. That preparation matters because during a spike, there is no time to debate what a metric means. Final question for this section. When load testing uncovers issues close to a launch or event date, how do you decide what to fix and what to accept as risk? A strong candidate might say this: I start by mapping issues to user impact and likelihood. Some problems look scary in graphs but rarely affect real users. Others may only trigger under very specific conditions. I work with the team to categorize findings into must-fix, nice-to-fix, and accepted risk. For accepted risks, I document mitigation plans, such as manual interventions or feature toggles. The key is transparency. I want everyone to understand what we are confident about and where we are taking calculated risks, rather than pretending the system is perfect. Let us shift into the harder questions now. These are the kinds of situations where there is no perfect answer, only trade-offs. Here is the first scenario. Your load tests say the system will probably survive the upcoming traffic spike, but confidence is not high. Leadership asks if you are comfortable proceeding as planned. What do you say? A strong answer would sound like this. I would avoid a simple yes or no. I would explain what the tests covered well and what they did not. I would call out specific risks, like which components are most likely to fail and what the user impact would look like. Then I would propose mitigation options, such as temporary feature restrictions or increased monitoring and on-call coverage. My goal is not to block the launch, but to make sure the decision is informed and that we are prepared to respond quickly if things go wrong. Next question. During a live traffic spike, error rates start creeping up, but everything is still technically within SLOs. Do you intervene or wait? A mature answer might be, I would not panic immediately, but I would not ignore it either. I would look for trends. Are errors increasing steadily or stabilizing? Are specific user paths affected? If the system is approaching known limits, I would take proactive steps, like scaling manually or enabling rate limits, even if we are still within targets. Waiting until SLOs are breached often means reacting too late, so I prefer early, controlled intervention. Another scenario. Your load testing did not catch an issue that only appears under real user traffic. Some teammates want to pause everything and redesign the test strategy. Others want to fix the immediate issue and move on. How do you decide? A strong response could be, I would separate short-term recovery from long-term learning. In the moment, the priority is stabilizing production and protecting users. Once that is done, I would push for a focused review of why the tests missed this behavior. That does not always mean a full redesign. Sometimes it is a small gap in assumptions. The key is to improve tests without overcorrecting and slowing future delivery unnecessarily. Next question. You are told to aggressively cut cloud costs right after a major traffic spike, but you know that keeping extra capacity reduces risk for the next event. How do you handle this tension? A thoughtful answer might be, I would frame the conversation around risk, not just cost. I would explain what capacity actually buys us in terms of resilience and response time. Then I would look for compromises, such as temporary buffers during known risk windows or more dynamic scaling strategies. If cuts are unavoidable, I would document the increased risk clearly so it does not come as a surprise later. Cost decisions should be explicit trade-offs, not silent assumptions. Final pressure question. After a traffic spike, everything technically worked, but the team is exhausted and stressed. Leadership calls it a success. Do you agree? A strong candidate might say. I would say it was a partial success. The system handled the load, which is important, but team burnout is also a failure signal. I would bring that up respectfully and suggest changes, like better automation, clearer runbooks, or improved load test confidence. Sustainable operations matter just as much as short-term wins, especially if these spikes are going to happen again. That brings us to the end of this interview simulation. If you watch this straight through, take a moment now to pause and reflect. Think about which question made you hesitate the most. Those moments usually reveal the areas worth practicing further. I encourage you to replay the questions, answer them out loud, and compare your reasoning to the sample responses. Focus less on matching the words and more on matching the thought process. If this was useful, subscribe so you do not miss the next interview simulation. Each one explores a different real-world DevOps challenge and pushes you to think under realistic pressure. And before you go, tell me in the comments which question you found hardest and why.